Hello, let us take another example to construct the inorderly both-way threaded binary tree. Now consider this binary tree whose nodes are given as here. So this binary tree is given and we will construct a threaded binary tree or inorderly threaded binary tree. So before doing that, let us write its equivalent in order traversing. Let us include another node also. So the in order traversing algorithm will return the following sequence. First it will print 120, then 90, then 150, 30, 100, 10, 30 and 20. So this is the in order sequence. Now here you can see that 100 points to 150. So 100 points to 150. Now 100 points to 10. Second, 150 points to both 120 and 30. Similarly, 10 points to 20 and 20 points to 30. So these are the normal links in the binary tree. Now we will start by considering the nodes which contains the null values. So here we include our special header node. The special header node will point to the first and last node in the in-order traversing. Now this is the in-order traversing sequence. Here 120 is the first node and 20 is the last node in the in-order traversing. So the header node or the special node will points to 120. So this will, the left part will point to 120. So let us use another different color. So this will point to 120. Now the right part of the special header node will point to the last node in the in order traversing, that is 20. So this is the first step. Now the second step is that we must 120 must point to the header, that is the first node under in order traversing will point to the special header node. So 120 will point to the special header node. Similarly, the last node in the in order traversing will point to the header node. So 20 will point to the header node. The right address part of 20 will point to the header node. Now we'll start by considering the nodes which contains null values. So first consider this node 90. Now this node 90 contains two null links. So this is 90. The left link of 90 will point to the in order predecessor of 90. So this is 90 and this node 120 is the in order predecessor of 90 and this node 150 is called the in order successor of 90. So 90 will point, the left part of the 90 will point the in order predecessor and the left part of the and the right part of the 90 will point to the in order successor. So this will call point to the in order successor of 90, that is 150. Now consider this node. Now we are considering this node. Now 30, 150 is the in order predecessor of 30. In order predecessor of 30 is 150. So the left part of 30 will point to 150. So the left part of the 30 will point to the 150. Now in order successor of 30 is 100. In order successor of 30 is 100. So the right part of the 30 will point to 100. So the right part of the 30 will point to the 100. Now consider this note. 10. In order predecessor of 10 is 100. In order predecessor of 10 is 100. So the left part of the 10 will point to in order predecessor. So this will point to in order predecessor. Now consider this note. Now this note. So in order predecessor of 30 is 10. So the left part of the 30 will point to 10. So this will point to 10. Now this portion. In order successor of 30 is 20. In order successor of 30 is 20. So the right part of the 30 will point to 20. So this will point to 20. So this is the way how we construct the threaded binary tree. Now in this particular example, the red color are used the thread address and the black color are used for the normal address. Now how the program will understand which is the red thread address and which one is the normal address, because both will contain the address value. So how to distinguish them? In order to distinguish them, we use the boolean field. Now consider the root node. Here the left part of this address of this node contains normal address, so its left flag will contain F. Left flag will contain F, indicate the left portion contains the normal address. Similarly here the right flag will contain F, that is the normal address are used. Similarly at here for this particular node, as the left address contains normal link, so the left flag will contain flag. Now as the right address part contains the normal link, the right flag will be false also. Now consider this node. Here the left address contains the threaded address, so here the left flag will be T or true. True means the threaded address, false means the normal address. So here consider the right one. Here the right address part contains the normal address, so it will be false. Now consider this node. The left portion contains the threaded address, so the left flag will be true. Similarly the right address also called the threaded address, so the right flag will be true. Now consider this node 30. Similarly the left flag will contain true, the right flag will contain true. Now consider this node. The left flag will contain true, but the right flag will contain false, because the right one contains the not threaded address. Black are the normal address or non-threaded address. Now consider this node. Here the left address contains the non-threaded address, so its flag value will be false. The right part of the node 20 will contains the threaded address, so the right boolean field will be true. Now consider the last node. Here the left address part contains threaded address, so the right flag will be true, left flag will be true, and as the right part also contains the threaded address, the right flag will be true. So this is the way how by using the special boolean variable we can distinguish between the threaded and non-threaded address. So these boolean fields are basically this field. So how we are using this field? If the left field contains false, we then consider the left address to be the non-threaded address. If the left field contains true, we will contains the left address to be the threaded address. Now, in case of right field, if the value of right field is false, then we will contain the right address as the non-threaded address. If the value of the right field is true, we will consider the right address as a threaded address. So we can write in this way that if left flag is true, then left address is thread address. If left flag is false, then left address is non-thread address. Or we can say the statement in this piecewise way also, that is left address, it may be non-thread address when if the left flag is false, it will contain the thread address if left flag is true. Similarly, in case of right address, we can say that if the right flag is false, then the right address will contain non-thread address. If the right flag is true, then the right address will contain the threaded address. So this is the way by which the program will decide which address is threaded address and which address is normal non-threaded address. Thank you.